In this Lightspeed tutorial, I'm going to run you through how to use ICM for docking ligands to proteins. So we see that we have all of these menus when we open up ICM, and we recognize that molecular editor perhaps. But first, let's notice that we can do a search of the protein data bank. I'm going to search for HIV protease. I suggest you do the same. Don't update it. It'll take forever. You can either, first let's just click this highlighted, this hypertext, and it takes you out of ICM to the PDB. But what we want is to click on the title, and then we see that ICM downloads that structure. And we can see a bunch of things appear. We can reset our Windows default layout and see that we have, yes, the protein structure. We can adjust the color and stuff. We'll talk about that more in class and a little bit later. But we can zoom in, and we see many directories here. We can get rid of some stuff that's cluttering our screen. We can resize things, such as the size of the graphics window. We can twirl the molecule to our heart's content. We can redisplay it however we want, but for now we're focused on docking. So let's pay attention to what's happening in this workspace panel. We can, these little blue icons, we can turn off and on different parts of the representation. We can make things bigger and smaller. But first thing we need to do for docking is to convert that document to an ICM object. So right click on the name, select all of these options for optimizing various components and replacing the original file, and then go. And we see that it only takes a second for the computer to reorganize that text file into an ICM object. We'll delete some stuff. We don't need that glycerol molecule. Next thing we'll do is right click on the ligand, BAI in this case, and move it from the object. That's important for doing docking. To set up our molecule for docking though, we can double click that guy to select the entire organic molecule, and then right click and choose neighbors, and we'll set the radius for our neighbor selection as 5 angstroms. We'll look in a list to choose what objects we'd like to dock, to find neighbors for, and then we'll make sure that that object is correct, A_2FLE, and we say okay, and then we get many atoms selected. If we, okay, well, I'll do that again. We select our ligand, hello, neighbors, there we go. Choose from the list, choose the right molecule. Notice that it's 2FLE, not 2FLE_1. There they all are. We can create a new docking project under the docking menu. We'll call it HIV-P for this. This is HIV protease. The receptor object is our first object, 2FLE. We'll choose the graphical selection already on the screen, noticing that there's a bunch of other ways to make the receptor maps. You can play with that. But today, we need to know that we've converted to ICM, we've taken the ligand out of our object, and off we go. And it creates these receptor molecules. You can see it's creating an energy surface, and it's waiting for input. So down at the lower left, we see stop or go. We'll go. It's telling us that it wants to create the box that it's going to do the binding in. We go, and it takes a moment to compute the receptor surface area, an energy surface, if you will, against which it's going to interrogate our ligand molecule. It's done, and now all we got to do is go back to docking menu, realizing that we can set up the docking in many different ways. We can bring a whole bunch of ligands in, or we can just say, let's choose the ligand we already have loaded here, and that's _1. Notice that over here, 2FLE_1 is our ligand object. We'll calculate an energy score. We'll use the current position. You can write a movie if you want for fun. You should display the run for fun as well. And we say okay. And it works through the docking. And once it's finished docking, we will see some new menu items appear in the workspace panel. Almost there. There. And now we see that we have under the ligand a stack of conformers, which we can open by clicking on the little arrow. And we see that we have a whole series of conformations. The top 20 or so conformations have been output. Oh no, I think there's 67 there, forgive me. And we can see that we can turn the ligand on and off, and we can step through those. There's a variety of ways of marching through those. We judge them according to the energy. The lower the energy, the higher the magnitude of the energy, the better the stronger the binding supposedly should be. We can turn off our receptor map and then just go back to our nice ribbon diagrams, and you can see the ligand that you've placed there. So what we can do now, aside from playing around with changing the representations, is going and making comparisons between the ligand that came with the structure we found as well as other ligands that we can draw and optimize within ICM itself. That's your challenge.